Hello students. In the last session we looked at solving quadratic equations. Well, today we're going to look at word problems which will require quadratic equations to solve. So let's look at the last section now in Chapter 5, which is section 5.6, and it's entitled Applications of Quadratic Equations. Okay, as I mentioned, we're going to be looking at word problems, and so before we actually begin solving some word problems, let's review the steps for solving word problems. So, I have on Elmo the steps for problem solving, and you have those in your notes from previous chapters. Number 1, the first step whenever you get a word problem is you want to familiarize yourself with the problem. That is, you want to read the problem carefully and then draw any necessary pictures. The second step is you want to let x equal your unknown quantity, meaning what you are looking for. The third step is you want to make an equation involving x. Then you want to solve the equation, which is the fourth step. And then finally, you want to check your solution to make sure it makes sense and then label it accurately with the proper units. Now again, you have these 5 steps to problem solving in your notes, and they're also in your book, so you can look at them if you need. We're now going to take a look at 3 word problems from this section, and I'm going to work at the board to do them. So let me pull up on font the first word problem for you. It reads as follows. The length of a rectangular calculator is 2 inches greater than the width. The area of the calculator is 15 square inches. Find the length and the width. Again, I'll repeat. The length of a rectangular calculator is 2 inches greater than the width. The area is 15 square inches. Find the length and the width. Okay, to do this problem, which is problem number 1, the first thing I'm going to do is I'm going to jot down some important information. I know that the length of the calculator is 2 inches more than the width. So length is 2 inches more than the width. So I'm just going to jot that bit of information down. And the second thing that I know about this calculator is I know that the area is 15, or 15 square inches. So the area is 15 square inches. So those are the 2 important pieces of information for this problem. Now, what I like to do is I like to draw pictures, because they always help me when I visualize a problem. So let me draw for us a rectangular calculator. The area of this thing is 15 square inches, and the length is 2 inches more than the width. So I'm visualizing a rectangle, and I know that the length is 2 inches more than the width. Well, you're actually looking for the width and the length, which you don't know. So the width is what you're looking for, and the length is what you're looking for, and you don't know what that is. So one of them you're going to call x, and the other one will be an expression in terms of x. Well, kind of makes sense to me. If I let the width be x, I can look at my picture. My width of the rectangle is x. The length is 2 inches more. Well, that must mean then that the length can be represented as x plus 2, or the width plus 2. So the length I'm going to let be x plus 2. So this is my defining the x stage, so I'm going to let the width equal x and the length equal x plus 2. Now, what do I know? I know that the area of this rectangle is 15 square inches. So that's what I'm going to use to write my equation. Area is 15. Area is also width times length, right? Area is width times length. So that means that if you take the width, which is x, times the length, which is x plus 2, you should get the area, which is 15. And let me highlight this again with a different color to remind you. This is your width, this is your length, and if you take the width times the length, you get the total area for that calculator. So that's where that equation came from. Okay, to solve this equation, what you first want to do is use the distributive property on the left side and multiply it out. X times x is x squared. X times 2 is plus 2x equals 15. And you should then observe that you have a degree of 2, which makes this a quadratic equation. And we know how to solve those. Remember, you want to get 0 on the right side. So you're going to move the 15 over, so you're going to subtract it from both sides. So you get x squared plus 2x minus 15 equals 0. And then you're going to factor and use the zero factor principle here. So the next step now is to factor this. So when I factor, I get x plus 5 times x minus 3 equals 0. Set each part equal to 0, and you get two possibilities. Either x is negative 5, x is negative 5, that results from the first part being 0, or x is 3, which results from the second part being 0. So negative 5 will make the first part 0, 3 will make the second part 0. I kind of skipped that solving part, but we practiced that, so you should be able to get to this line right here. And now you want to check and see, okay, do both of these answers work in my original problem? Well, what did x represent in your original problem? X represented the width. Can width ever be negative? Well, no, that doesn't make sense. Negative 5 inches for a width? No, that negative answer doesn't make any sense in this word problem. It is a solution to the equation, but it doesn't make any sense for the word problem. So negative 5 can't work. Does 3 work? Well, 3 would make sense. You can have a width of 3 inches, and in fact, if you think about it, a calculator is about 3 inches long. So let's write our solution now. So the width looks to be 3 inches. And if your width is 3 inches, your length, remember, is 2 inches more. Remember, your length is 2 inches more, and so your length has to be 5 inches. 2 inches more than 3 is 5 inches. And if you take 3 inches times 5 inches, you get a total area of 15 square inches. So in fact, those two answers are the correct ones. Okay, so your width is 3 inches and your length is 5 inches.